All right, so there were also some questions about the volumes of revolution, so hopefully I can sum this up in 10 minutes or less. So we have what's called our disk method, and then we also have our washer method, all right? And the disk and the washer methods are very, very similar to each other. The disk method you use with one function. All right. The washer method you use with two functions. All right. Both of them are based upon the area of a circle. So the area of a circle is pi r squared. Okay. So the way these work is, and we're going to talk about the disk method first. All right, is that if you have a function, some arbitrary function, f, if we measure this distance here, that is f of x, and we're rotating around the x-axis, it's going to create a little disk, or really a sideways cylinder is how you can think of it, where this would be the x-axis going through it, where you have your radius. So if area is pi times radius squared, our area would be pi f of x squared. All right. So if you remember from the other video I just posted, when you want to find volume, volume is the integral of area. So we'll have our bounds a to b of pi f of x squared dx. And usually the way we write this to make life easier is that we say volume is pi, the integral from a to b, f of x squared dx. We just factor the pi out to make life a little bit easier. So that's how the disk method works. All right. Now there's also what's called the washer method. The washer method involves two functions. So we'll do this as f of x, and then we'll do this as g of x. And again, we're going to rotate around the x-axis. So what ends up happening is, and we're going to look at this region here in between the two, okay? So this will be point A, and that'll be point B, okay? So really the way this works is it's just like doing the area between two other objects, the area between two curves, where you have a top function and you have a bottom function, all right? So you have your function f of x. So let's see if I can draw this now. You're going to end up with basically one disk that looks like this. This will be my graph of f. Okay, but then when you rotate g around, you get another guy in the middle. It's kind of hard to do with two dimensions like that. Okay, so what we have here is we have big R for our outer radius, and then we also have little r for our inner radius. Okay, so both of these r's are radii. So you have your big circle with a big disk. Area is pi big R squared. You have the little disk. Area is pi little r squared. Okay. So you can just do the difference between these two. So it'd be the integral of a to b pi big R squared minus pi little r squared dx, and then we just factor out our pi. Pi, the integral a to b big R squared minus little r squared dx. And that's how, this is called the washer method. And that's how the washer method works, because this picture here is a washer. All right, so hopefully that answers some questions for all of you. If you have anything else, you know my schedule online or email. Thanks. Keep it up.